All right, let's pull back the curtain on the digital world. Today, we're going to be architects. We're going to look at the absolute fundamental building blocks that power pretty much every single app and website you use every day. This is the invisible skeleton that holds it all together, the database. So let's get building. You ever stop and think about that? It feels kind of like magic, doesn't it? You know, you close an app, you come back hours later, and it just knows who you are and what you were doing. Well, it's not magic. It's a really carefully constructed system. And today, we're going to see exactly how it's built, one digital brick at a time. So, here's our game plan for this digital construction project. First, we'll look at the blueprint, the overall structure. Then, we'll pick out our building materials. After that, we'll create a unique ID system for every single part, connect all the blocks together, and finally, we'll set some ground rules to make sure the whole thing is absolutely rock solid.
Okay, first things first, the blueprint. You know, every great project starts with a solid plan, and in the database world, that plan always begins with a super simple but incredibly powerful idea, the table.
And you've totally seen this before, right? It's just a table. It looks a lot like a spreadsheet. We've got columns that define what kind of data we're storing, things like name, email, or age, and then we have rows, and each row is its own individual record. It looks simple, I know, but trust me, this basic structure is the foundation for everything we're about to build. So, now that we have our blueprint, it's time to choose our building materials. I mean, you wouldn't build a house using only wood, right? Same thing with a database. We need to be really specific about what kind of information goes into each column. And that's where data types come in.
Think of a data type as a super strict bouncer for your data. It stands at the door of each column and basically says, nope, sorry, only numbers are allowed in here, or this column is for text only. This is absolutely crucial because it prevents errors and keeps our data clean and reliable. You wouldn't want someone's age to be stored as the word blue, right? Well, data types are what make sure that kind of thing just can't happen.
And this is a perfect example of picking the right tool for the job. We have integer for whole numbers, perfect for things like a user ID or how many items are in a shopping cart. Then you've got varchar, which stands for variable character. It's super flexible, so it's great for stuff like names or user comments where the length can change. And why does this matter? Well, choosing the right data type makes the database way more efficient, which saves space and makes everything run faster.
And of course, the toolbox is full of these things. If you need to answer a simple yes or no question, like, is this user a premium member? That's what Boolean is for. It's just true or false. And naturally, we have date for storing, well, dates. Each one of these has a very specific job to do, and that ensures our data is always stored in the most accurate and efficient way possible.
Okay, so our foundation's poured and we've got our materials picked out, but we have a problem. A big one, actually. What if we have two users named Jane Doe? How does the system tell them apart? We need a completely foolproof way to give every single row of data its own unique identity.
And the solution to that problem is the primary key. The best way to think about it is like a license plate for your data. Each row gets its own unique ID number, which usually just counts up automatically. So even if two rows look exactly the same, their primary keys will be different, and we can always tell them apart. This is the secret to avoiding all sorts of confusion and making sure our data is managed with total precision.
Now this is where things get really cool. Since every single piece of our structure has its own unique ID, we can start connecting them all together. This is where a database goes from being just a bunch of separate lists to a powerful, interconnected web of information.
So check this out. It's actually pretty simple. Over on the left, you see our users table. Each person in there has that unique user ID. That's their primary key. Now look to the right at the post table. To connect a blog post to the person who wrote it, we just put a user ID column in the post table too. That user ID on the right is called a foreign key. And just like that, bam, it creates a link back to the original user. Now we know exactly who wrote which post. It's that simple and that powerful. All right, we're on the home stretch. We've built our structure, we've got our materials, and all the pieces are connected. The very last step is to set some ground rules. You can think of these as the official building codes for our database. They're called constraints, and they are what make our digital creation reliable, robust, and worthy of our trust.
I absolutely love this analogy because it is so true. Constraints are literally the laws of physics for your database. They are the non-negotiable, unbreakable rules that stop bad data from ever getting into your system in the first place. This is what guarantees the integrity of the entire structure right from the very foundation.
And here are some of the heavy hitters. Not null is a big one. It just says a field can't be left empty, like a required email address. Unique is what prevents two users from signing up with the exact same username. Default is handy. It provides a fallback value if you don't specify one. And check lets you get creative and write your own custom rules, like making sure the price of a product can never be a negative number.
So let's just zoom out for a second and look at what we've put together. We started with a simple table. Then we chose our materials with data types, gave each piece a unique ID with primary keys, connected everything with foreign keys, and then locked it all down with constraints. It's these 5 fundamental building blocks working together that power everything from your social media feed to your online bank account. It's the hidden architecture of our modern world. So here's a little challenge for you. The next time you're using an app, try to see these building blocks in action. When you sign up and it says, "Sorry, that username is already taken," that's a unique constraint at work. When your shopping cart remembers everything perfectly, that's the power of primary and foreign keys. These blocks are absolutely everywhere, silently making our digital lives work. What other examples can you spot?